Hello and welcome to another video. In this video we are solving a systems of equations problem to ultimately solve for x plus y. So we have x squared minus y squared is equal to 24, and we have xy is equal to 34. So we're going to go through two different ways to solve this problem. For some of you the first might be easier, some the second. Personally, I like the second way more, but the first one works as well. So for the first one, we're going to start with x squared minus y squared is equal to 24. And now we're going to apply an exponent property that if we had a squared minus b squared, that would be equal to a plus b times a minus b. So in this case, our a and b values are x and y. So then we would have x plus y times x minus y is equal to 24. Now, what we're going to do is we're going to square both sides of this equation. So if we simplified this square root here, we would end up with an x plus y squared times an x minus y squared, and then we have our 24 squared. Now we're going to apply two exponent properties. So the first one is if we had a plus b squared, that is equal to a squared plus 2ab plus b squared. And if we had a minus b squared, that would be equal to a squared minus 2ab plus b squared. And so that works perfect for our case because we have an x plus y and an x minus y. So if we applied that, we would have an x squared plus 2xy plus y squared times x squared plus 2 or minus 2xy plus y squared is equal to 24 squared. Now, as always, if we are moving fast, please pause or slow down the video and change the speed according to your taste. Now if you notice, we can go ahead and recall that we have an xy here, and we know that xy is equal to 35. So we'll write that over here, nice bright green. So now we can substitute our 35 value in for the xy, so we'd have x squared plus 2 times 35 plus y squared times x squared minus 2 times 35 plus y squared is equal to 24 squared. Now if we go ahead and simplify this, our 2 times 35 would ultimately be 70. So we would have x squared plus y squared plus 70 times x squared plus y squared minus 7. Now what we can do is we can rewrite x squared plus y squared on both sides of these in their own parentheses, just like so. And that's important because I will show you. Let's get a new slide. Since we have it in this form, we can apply an exponent property, and that is if we had a plus b times a minus b, that would be equal to a squared minus b squared. So in this case, our a value can be x squared plus y squared, right? And then our b value would be 70 because we have a plus sign, and minus sign. So if we did that, we would have an x squared plus y squared squared minus 70 squared is equal to 24 squared. Now what we're going to do is we're going to add 70 squared to both sides. So we're going to move it over to the right. And then if we solve for these two squares here, 24 squared would be 576. And 70 squared would be 4,900. So we add those together, we'd still have x squared plus y squared squared is equal to 5,476. Now in order to solve for this exponent here, we're going to take the square root of both sides. And so our square roots would cancel, and then the square root of 5,476 would be plus or minus 74. Now that we're at this point, I want to recall that xy is equal to 35, and now we're going to use an exponent property. And so pause if you need to think about this, but So we have a plus b squared is equal to a squared plus 2ab plus b squared. So what we're going to do is we're going to reorganize this equation a little bit. But in our case, our a value is going to be x and our b value is going to be y. So we would have an x plus y squared is equal to x squared plus y squared plus 2xy. And we know xy is 35, right? So we would have x plus y squared is equal to plus or minus 74, because x squared plus y squared, right, is plus or minus 74. And then 2xy, xy is 35, we'd have plus 2 times 35. So let's get a clean slide. Our 2 times 35 would turn to 70, right? So we would have x plus y squared is equal to plus or minus 74 plus 70, which will give us two options, right? We're going to have a 74 plus 70, which would be equal to 144, or we're going to have a negative 74 plus 70, which is negative 4. So if we were to first work with our left side, we'd have x plus y squared is equal to 144, and in order to solve for the square root here, we're going to square both sides. And the square root of 144 would be plus or minus 12. So x plus y is equal to plus or minus 12, which is perfectly what we're solving for, right? So two of our solutions would be plus or minus 12. So working with our right side, we'd have x plus y squared is equal to square root of negative 4 squared. Our squares would cancel. Now the square root of negative 4 is the same thing as the square root of 4 times the square root of negative 1, right? And negative 1, the square root of negative 1 is equal to I. I have a video on that if you need to learn more on that. And the square root of 4 is 2, so we'd have plus or minus 2i. So x plus y is equal to plus or minus 2i. So these are our four possible answers to x plus y for this system of equations. So let's go ahead and solve this another way. So in this case, we're going to take our xy is equal to 35, and we're going to solve for x. So we're going to divide both sides by y. We're going to be left with an x is equal to 35 over y. Since we now know what x is, we can plug that in to our x squared minus y squared is equal to 24. So we have 35 over y squared minus y squared is equal to 24. If you're unfamiliar, this method is called substitution when it comes to systems of equations. But let's solve for this. So we would have 1,225 over y squared minus y squared is equal to 24. And now if we multiplied both sides of this equation by y squared, our y squared here would cancel. Y squared here would turn it into y to the power 4, and then we have 24 y squared. If you're not tracking, please pause and look at it. But we're just multiplying the whole equation by y squared. Now what we want to do is we want to move our 24y squared over to the left side, so we'd subtract that from both sides, like so, and then we want to format it accordingly with our highest exponent at the front. So we'd have minus y to the power 4 minus 24y squared plus 1,225 is equal to 0. Now what we're going to do is we're going to say that u is equal to y squared, hence u squared would be equal to y to the power of 4. So in this case we would have a negative u squared minus 24u plus 1,225. Again, please pause or slow it down if you need to, but clean slide. We are going to use the quadratic formula to solve for u. Now the quadratic formula is this. If you're unfamiliar with it, I have a video on it. Please go check it out. But otherwise, we would plug in our a, our b, and our c value, and we would have a negative times a negative 24 plus or minus square root of negative 24 squared minus 4 times negative 1 times 1,225 all over 2 times negative 1. Now because we have our plus or minus here, we're going to get two different answers. We're going to have a u is equal to a negative times a negative 24 plus 74 over 2 times negative 1. And same thing, except we're going to have a minus value here instead of a plus value. So if we first solved for our left option over here, that would be equal to negative 49, right? 24 plus 74 would be 98 divided by a negative 2 would be negative 49. Now, our right side would be equal to 25. We'd have a positive 24 minus 74, right, would be negative 50 divided by a negative 2 would be positive 25. Now, if we can go ahead and recall, up top right corner here, u is going to be equal to y squared, right? Now we have a u value here, so y squared would be equal to negative 49. So we're going to take the square root of both sides. So y is going to either be a positive square root of negative 49 or a negative square root of negative 49. And the square root of negative 49 would be 7i, because we can pull out our square root of negative 1, which is equal to I, which we previously talked about in the other example. And same thing, we'd have negative 7i. So those are two of our y values. Our right side over here, again, we'd have y squared is equal to 25. We would square both sides. We'd have a positive square root of 25 or a negative, which would leave us with a positive 5 or negative 5 value. So currently, all four y values we have are 7i, negative 7i, 5, or negative 5. Now what we're going to do is we're going to plug these solutions, all four of these, into xy is equal to 35. Our goal of this is to solve for x. So these are our four plugins, right? We plugged in our 7i, negative 7i, 5, and negative 5, all for our y values, and xy is equal to 35. So let's just solve for that. We would first have a x times 7i is equal to 35, so we divide 7i on both sides, which would leave us with a negative 5i. And if you're unfamiliar with having I as your denominator, you would multiply both the top and bottom by negative I, which is why we have a negative value here. So in this case, similar situation, we're dividing both sides by negative 7i, which would leave us with a positive 5i. Here we divide both sides by 5, we would be left with 7, and then divide both sides by negative 5. And we would have negative 7. So if we put all of our x and y values here, right, this is where we have solved up to this point. We know what x and y is equal to in each scenario. Now what the problem is asking for is we want x plus y, right? So this is where we can just add across. A negative 5i plus a 7i would be 2i. 5i plus negative 7i would be a negative 2i, so plus or minus 2i. Then 7 plus 5 would be 12, and negative 7 minus 5 would be negative 12. So we'd have plus or minus 2i and plus or minus 12. So that wraps up two different ways you can solve this problem. Please comment down below which way you found easier. And if you found this video helpful, please like and subscribe And as always, comment down below with any questions. Thank you for watching.